At this point, we are familiar with pointers and pointers to pointers. I have a quick example here. We have an integer variable called var, and I initialize that to 55. Then I have a pointer to an integer called ptr, and we initialize that to the address of the variable var. Next, we have a pointer to a pointer, and the pointer to the pointer is going to store the address of the pointer. Okay, we use the address of operator to fetch the address of the pointer ptr, and we store that in the pointer to pointer. Now this lesson is about the reference to the pointer. So we get to this sort of syntax. We have a reference to a pointer to an integer. Okay, again, reading from right to left. And you have to think about what a reference is. A reference is an alias for something else. So reference to pointer is an alias for the pointer, ptr. That means you can dereference the reference to the pointer as you can with the pointer ptr. That is whether you want to change the value that is stored in the variable var indirectly through the pointer ptr or through the reference to the pointer. You can also fetch that value by dereferencing, so whether you want to do console output or some computation, again using the indirection operator followed by ptr or indirection followed by the reference to the pointer, because the reference to the pointer again is just an alias for ptr. Okay, so you'll see some examples of this throughout the rest of this lecture. I'll start with a simple example in the main function before we move on to passing by references to pointers and so on. To get started, I have a couple of variables. I have a variable here, integer variable, which we initialize to 55. And then I have a variable to assign, which I initialize to 250 here. Then I have a pointer in the next statement. I pointer to an int called ptr, and I assign the address of var to that. Then I have the statement before, and I print out, I dereference ptr to print out the value that it is pointing at, which is 55. Then next I want to declare and initialize a reference to a pointer. Okay, so we've seen a pointer before. Now we have a reference to a pointer to an integer, which I'll just call reference to pointer. And that is basically an alias for that pointer, right? So let's make a change to that. I'm assigning the address of variable to assign to that reference to pointer. And what does this mean? Well, basically we're assigning the address of the variable to assign to the pointer ptr itself, because reference to pointer is an alias for that. Then I do this printout after, and I dereference ptr again. If we build and run, we get the output that we would expect. Before we get 55, and then of course the pointer is now pointing to something else. So if we dereference it, we get 250 now. Finally, reference is already constant. You cannot make the reference something else, right? But what we can do is we can make the reference to the pointer a reference to a constant pointer to an integer. And then we cannot do this assignment. The expression must be a modifiable L value, okay? So I'll comment that out and build and run that. And now we get 55 each time because we cannot go and change the address using the reference to the pointer. I'll undo this. Okay, so reference to pointer is a reference to a pointer to an int. And now what we can do is we can use the reference to the pointer as if it is the pointer itself. I can dereference the reference to the pointer, and then I can assign 75 to that, and then I can print that out again. In this case, I'm dereferencing the pointer itself, ptr. Build around that, and after now prints out 75. And we can also dereference the reference to the pointer. So in this case, for example, in the console output statement, I'm dereferencing that reference to pointer to fetch the value, which is similar to what we do here with the pointer itself. Because the reference again is basically the same thing, it is an alias for the pointer. If I build run now, we should get 75 again, so we get 55, and then after we get 75. Again, this is just to demonstrate that we can basically now use the reference to the pointer as if it is the pointer itself, because the reference is an alias for that pointer. Now we can actually also do something like a reference to a pointer, but that is not really something that you'll use or come across. I just wanted to mention it here. Okay, I hope this section was interesting. We'll move on now to a couple more examples. In the next couple of examples, we're going to look at passing a pointer by value, passing a pointer to a pointer, and passing a pointer to a reference to a pointer. Basically, what we want to do with this modify pointer function is we want to assign a new address to the pointer or to a pointer. And in this example, to get started, we'll look at passing a pointer by value. In upcoming examples, we will overload this function. Okay, so the first formal parameter is a pointer parameter, which is a pointer to an int. And then the second formal parameter is the address to assign, which is also a pointer to an int. Okay, so we'll get the address that we want to assign to the pointer in this parameter, and then in this statement we assign that address to the pointer parameter. Now in the main function I have two variables here, both of type int. The variable here which we will assign an address of that to a pointer, ptr, which is a pointer to an int, and another variable here, variable to assign, that is initialized to 250. Then I have a console output statement before passing, and I do reference the pointer to see what the value is that it is pointing at currently. Then I invoke the modify pointer by passing in the pointer, and then we get the address of that variable to assign. Again, we want to pass in an address because the second formal parameter is a pointer, so we cannot just pass in the variable itself. And then we do another statement here, another console output statement after passing, and we do reference pointer once more. Basically we want the after passing to print out 250, right? But if I build a run with this function currently, it will not modify the pointer in the way that we want. Before passing and after passing we will get 55 printed out both cases. And maybe you can pause the video and think about why that is for a second. Alright, we are passing by value, so the formal parameter here, the pointer parameter, is a pass by value. So instead of modifying the pointer that we pass in here, ptr, we are modifying a copy of that. The pointer here is a copy, and the original pointer in the calling function, in this case main, ptr here, okay, that we pass in, that is going to remain unchanged, so it is still going to store the address of var here. Okay, it is only the copy, the pointer parameter, that stores the address that we assign here. And of course, once we exit this function, modify pointer, the local pointers ptrp and address to assign will get destroyed. Okay, so moving on, I'll copy this function, and I'll go and overload that. We want to pass a pointer to a pointer. And so that first formal parameter I'll change to a pointer to an int here. Now we have to think about this for a second. Why do we get an error here? A type pointer to int cannot be assigned to an entity of type pointer to int. What does this mean exactly? Well, remember, a pointer to a pointer stores the address of a pointer. So by having the identifier itself, the pointer parameter here is now currently a pointer to a pointer. We are trying to assign what to that exactly? Well, this is going to return some address, but it's not going to be an address of a pointer. It is going to be the address of this variable to assign. So what we want to do is we want to dereference that pointer to pointer once. Okay, maybe to make this more clear, I'll go back to the main function here, and I'll copy this line. I'll keep the original line just for reference here, but I just want to do single printouts for this demonstration. We're going to invoke the modify pointer, and then I'm going to pass in what? Well, we want a address of a pointer, okay? This overload modify pointer as a formal parameter, which is a pointer to a pointer, and a pointer to a pointer stores what? It stores the address of a pointer. So we pass in the address of the pointer ptr, not ptr itself. In this line again, if we only had ptrp here, what we would have to assign for this to work would be a address of a pointer, but we are currently trying to assign the address of a variable. So by dereferencing that once, what happens when we dereference that once? Well, firstly again it stores the address of the pointer here, ptr, and by dereferencing that once, we get the address that is stored in the pointer itself, ptr. And now that is an L value, so we can assign to that, we can modify that, and we modify that by assigning a new address to that, which is the address of the variable to assign, which we pass in right here. We pass in the address of variable to assign in. It gets accepted by this pointer. Again, this address to assign pointer now stores the address of that variable. That should now work fine. I'll build around that. And you can see it now actually does modify the address that is stored in that pointer successfully, and now we get 250 printed out. That is following the function invocation. Now of course you can go in and print out the addresses of these functions and these variables and so on, but I'm not going to do that for right now. We can see that the function works as we want with passing by a pointer to a pointer. Finally, we want to demonstrate passing to a reference to a pointer. And again, the compiler will deduce which function overload to invoke based on the arguments that we pass in. Here we want to pass to a reference to a pointer. So we want to change that formal parameter. The type of the pointer parameter is now going to be a reference to a pointer to an int. This is no longer a pointer to a pointer, so it no longer stores the address of a pointer. So I can remove that dereference. It is now basically an alias for a pointer, similar to passing by reference. The reference parameter is basically an argument for what we pass in. In this case, we have an alias. For what type of argument? A pointer to an int, okay? So we pass in a pointer here, and I can actually remove the address of operator. We no longer want to pass in the address of the pointer. We want to pass in the pointer itself, so we can create an alias for that in the function invocation, but now we'll have a problem. More than one instance of the overloaded function modify pointer is going to match those arguments. So what we can do is, just for this demonstration, I'll just comment this out here. Since this is not really what we want to do, we want the function to modify, or in other words to assign a new address to the pointer. This should now work fine. I'll build and run this. And you can see this works fine. Before passing we get 55, after passing we get 250 printed out. I prefer to pass by reference to a pointer instead of by pointer to pointer because it's easier to work with. You get an alias, and then you don't have to do that weird referencing stuff. It's not that often that you need references to pointers, but I thought I'd demonstrate this to you, because you may run into a situation where you need this or where you see this in other people's code, so that you understand what a reference to a pointer is.